Welcome to Extreme Light Infrastructure Nuclear Physics. This video will give you a tour of the Gamma Spectroscopy Lab located within the special building of ELI-NP. Just as we enter the lab, we can find the glove box on the left-hand side. This sealed container encloses a controlled atmosphere into which we can introduce and then safely manipulate objects with hazardous properties, such as liquid scintillators that have low flash points. The adjacent clean room is used to work on devices that need special conditions during assembly or repair. An example would be the mounting of silicon detectors on a dedicated structure. Since the clean room is ISO 5 certified, it prevents the buildup of dust and other harmful particles that would otherwise contaminate the delicate electronics. The clean room is also the home of our time projection chamber, which helps us measure reactions relevant to nuclear astrophysics. The nearby positioning table can hold objects with a mass of up to 10 kilograms and is used for performing transmission radiography and tomography via nuclear resonance fluorescence. At the back of the lab, we keep our charged particle testing arrangements. The first is an experimental setup dedicated to nuclear astrophysics measurements called ELISA. After its reaction chamber, silicon detectors, and electronics will have been fully tested within the gamma spectroscopy lab, ELISA will be moved to its dedicated position in experimental area 9. Next comes a setup for testing charged particle detectors and other devices that operate in vacuum. It comprises of a cubic vacuum chamber and a rack for the associated electronics and acquisition system. The silicon detectors currently being tested are to be placed inside the vacuum chamber, while a radioactive source will be introduced via the motorized stage. Our beam energy station was built for monitoring ELI's gamma beam. It features a high-purity germanium detector and an annular scintillator. An anti-Compton shield surrounds the HPGe detector to suppress the resulting Compton events. The two detectors are connected to a digital acquisition system for recording incoming data and building the energy spectra. Finally, our beam profile station is still undergoing assembly within the lab. It uses a scintillator and a CCD camera to record and measure the spatial profile of the gamma beam. Once completed, the beam profile station will also be moved to its dedicated position in experimental area 8. This concludes our tour of the Gamma Spectroscopy Lab and its associated setups. We hope you've enjoyed your time learning more about ELI-NP, and we'll see you in the next video.